So I gotta go over and check and see if we're good to go. We're green light. We're good to go. Thank you. So I'm not really going to spend a lot of time on this one. This is systems of non-linear equations. So you might get a quadratic with a line. If you did have a quadratic with a line, then how many solutions should you have at most? Two. You can get one solution or no solutions. There's no way to get infinite solutions.
I thought that was if they were the same line.
Yeah, there's
If we're talking about a quadratic and a line. So these are systems of non-linear equations. So here's what we're going to look at. Recognize systems that are non-linear in two variables. Solve non-linears by substitution, by addition. We probably won't spend our time doing that because we already know we have. What do we have?
Matrices.
Calculators.
Oh, we have that.
And then we just find the point of intersect from them. Okay? You mean section? One of those in chapter 7.
7.3.
Yes, there you go. Waterfalls. So, you should recognize that if an equation is going to be linear, it's going to be in the form of ax plus by equals c, where x and y both have a degree of 1. If it's any other degree, then it would be nonlinear. Because in order for it to be linear, they both must be in the first degree. Don't need to really know that, do we? Kennedy? No? Okay. Solution of nonlinear systems in two variables is an ordered pair. We call that a solution set, and we always put it in the form of x, comma, y, because I told you to. Is this a linear system? Mm-mm. Now, of course, you could throw that into the graphing calculator. You will have to solve it for y, but it'd be okay. And then, does anybody need to see that on the calculator? Or should we do this by hand first?
Do it by hand.
You want to do it by hand first? All right, let's do this. It's still going to be the same as before. What you're trying to do, in this case with some substitution, is to try to get rid of either the x's or the y's. In this case, let's do this. We're going to go x squared minus y is equal to a negative 1. And then we can do, did I want to do that? Well, I kind of do because I want to swap this one. And I'm going to swap the 1 with the y. So this will be 4x plus 1 is y, correct? So what's the value on y? 4x plus 1. So then I have x squared minus 4x plus 1 is equal to negative 1. X squared minus 4x equals 0. Oh, I'm not going to skip steps, sorry. Minus 1 equals minus 1. Right? So those minus 1s kind of cancel each other out. Or they make a 0. Right, ladies? So we've got x squared minus 4x is 0. You could factor out x. You could factor out x, and that would leave you with x minus 4. That means that x is 0, and it's 4. So when I make my coordinates, I'm going to have a 0, and I'm going to have a 4. So to figure out the corresponding y's, you're going to plug those back in. So what's 4 times 0?
0.
Plus 1. So here I have one solution. Let's plug in that 4. And then the other one's going to go with 17. So you really have a product that crosses twice.
Actually, pretty much. So
Pretty much, you're fired.
You're all fired.
down, left, right, side to side, diagonal.
Northwest, east.
Southwest.
Yeah, we did a concert like a month ago, and we got some instruments, so I got mine last week.
I wish I was a part of that. I pretty much was. Wait.
And I get what? The solution? Well, here, look at this. We know that x times x minus 4 equals 0, right? So use the zero product rule. That means that either x or this number is 0. So if x was 0, then there's 1. And then if this was a 0, then 4 would be the solution, right? So that gives me the two x's. Then I just got to plug them into this equation to figure out the corresponding y's. Input outputs. Okay, Can I get it old school? Yeah.
He said like
I can erase it. Want that, Maddie? No need to write this down? No need to write this down? Okay. Okay. I can erase it? Anybody still writing? Tú, amigo? You're done? Okay, cool. Hey, that's the only part that I didn't do. You should always check your answers. Because if one of them doesn't work, I think a lot of people missed that on the last test. Ladies. Because you put down 2 solutions and one of them didn't even work. So it's wrong. You fools. You lost points. Okay, going. Next one. Different system. Oof.
I'm just gonna plug that in.
No, this one you would just use the elimination method.
Oh.
For this one, you can just use the elimination method because they're the same variables. You don't have to worry about crossing those x's and those x squares. So you can just go about it the old school way. Try to change them so that they have some type of common factor, and then do opposites of each other at this point, right? So we multiply the top by 3, the bottom by a -2. That's going to make this system. Then you're going to add them. These are going to fall out the picture, and you're going to get x squared equals this. Take the square root, that gives you plus or minus 3. Take that plus minus 3, plug it back in. Now, notice that these are 2 circles, right? 2 circles. The only way, what you can get with 2 circles is you're going to get 2 solutions, right? Anywhere that, like, if they intersect, they'll intersect at 2 points. Or you can get where they just are tangent to each other, which is 1 circle. And then you could probably get the scenario where they're that same circle, and then that would be, no. Is that circle really infinite? Technically, yeah, that's true. You could, because, no. Yes and no. Yes and no.
Yes or no.
Technically, I'm gonna have to say no. I'm gonna have to go with Skulls on this one because if you think about if you go on the if you did this, let's think about this for a minute. This is like a stats kind of thing when we do probability. Let's say we had a circle, okay, and we only went from let's go 0 to 1 degree, right? Technically, how many different numbers are between 0 and 1? Real numbers. There's an infinite amount of numbers because I can always go. Let's say I could take half of that, right? And I could take half of that, and I could take half of that. I could take half of that. How long could I take half of a number for? Forever. And I didn't even cover the other half of that. And I didn't even cover the rest of the 360 degrees. So technically, yeah, they could be infinite solutions, but this is not a very difficult idea either, right? We're good here? Wait.
Keep going.
That's how we've been doing. Even with systems of linear equations.
Plug X back in, right?
Yeah, so what you'll get is you'll get that X, pick one of the 2, plug them in, spit out a Y for both of them. What's up?
So you're multiplying one of the
Yeah, well, if you look at this, what we decided to do here was to multiply this equation by 3 and this one by negative 2 so that the Y's would drop out of the picture. Did we have to do that? That's elimination. That's what we've always done with elimination. Okay? It'll save. And then I have to worry about it next year. All right, cool. Plug them back in, get up the other values, and then you got your solutions. 4 solutions? How did you get 4 solutions?
Well, because of the plus or minus.
Oh, possibilities. Okay.
Yeah.
So let's go on. Application.
What do they call it?
I don't want to apply. I want to find the other stuff.
The pool rat.
Oh, yay.
Yay!
That means that we don't need to do tomorrow.
Or we could do today's lesson. Yesterday, tomorrow's lesson today.
Yes. Oh, yeah. Walk into tomorrow.
Uh-oh.
Yay! Systems of inequalities. This is something you've also already done, right?
Is this tomorrow's lesson?
This is tomorrow's lesson, so yeah, if you don't want to do lesson tomorrow, then we'll get out of the way. None of this is resulting to be something new. You've already should have done it. You should have started this in Algebra 1.
The shading.
You should have done it in Algebra 2, right, with the shading. So, linear equality,
Also
two variables. Cool beans. So, I don't really need to go through any instructions, right? You guys remember how to do all this? So, if I wanted to sketch this, anybody use the two-intercept method? I should have an intercept at -4 on y. So 1, 2, 3, 4. And I should have another one at 2. So here's my line. Yeah, should be solid.
No, do it slow.
Hold on, what, you guys serious?
No, I remember. No, I don't.
Waterfalls. Let me start this again. This is easier if I use the two-intercept method. To find a y-intercept, I make x 0, don't I? So if that's 0, then what would that quotient be?
Oh, -4.
-4. That means that I should have 0, 1, 2, 3, 4. Right there. And if I want to find an x-intercept, I make y 0. So if that's gone, then I get 2. So 1, 2. There's my point. And I'm using a solid line. I'm using a solid curve.
That is a very straight line.
I'm using a solid curve. Now, no, this has been done for like a long time. Now, you're shading because it's not in that y equals form. The easiest thing to always do here is to check 0, 0. If that's 0 and that's 0, that's gone. Is 0 bigger than 8? Is 0 bigger than 8? No. So I don't shade this side, I shade the bottom of it.
That's not even how I do it.
It's just taught me Algebra 1 all over again.
You destroyed my Algebra 1 career.
I used to spend so much time like shading it in so it's pretty.
Oh,
I'll usually just do one line to highlight, so that's
That looks like somebody girls would make it IHOP with the yogurt when we're little.
Waterfalls! How did this become a topic of discussion? Let's move on. Oh, people writing this down? Okay, good. That's a smart idea. I worn it out so
I guess I have some good friends in my life. She's like, give me
I don't have any notes.
give me like a go-gurt.
Oh well.
Did you just put something 3 times within the past 1 year?
Waterfalls! Thank you. Does anybody need to see the other method with the y equals equation?
No, I feel like that's a lot easier. What if
I think so, but I just want to double check because there's some people that don't know what I did. And you see the other one? You want to see the other one?
No, so if it's less than 0, it's above, and if it's greater.
Well, you're just looking for a true statement, right? If I'm testing the point, if I'm going to test this point, 0, 0, what's 4 times 0? And then -2 times 0? And 0 plus 0 is 0, right? Is this true? No, so I wouldn't shade it because that's not a solution. So I jump to the other side. If it was true, no. Because if this one doesn't work, then the other one side has to. It can only be one region. Okay? Unless it was equation equals, and then neither side would work. It would be that line. Okay. Oh, hold on. I gotta erase this. I forget. You're good, Kennedy?
Yeah.
All right. Mr. Kennedy. Look at all this work. Jesus. Jesus Cristo. How many is that? 4 slides already? See, there's our shaded region.
Wait, go back. Never mind.
Okay, so. Shh. Shh. I didn't even finish it. I didn't even start it. This is a circle. I'm centered at 0 with a radius of 1, 2, 3, 4. This is a solid circle, or a solid line, I should say. And then again, just you're either going to shade the inside of the circle or the outside. Test the point 0, 0. Is 0 bigger than 16?
No.
No, so then you shade all the
Looks like a lion. Yeah.
shade all the outside.
Because
X and
the
Y are
X
both
is
squares.
squared.
Because
What happened?
X squared equals a parabola, Y squared equals another parabola, and it makes it square.
That's not necessarily true because x squared is a parabola and y squared is a sideways parabola, so you would have a quarter piece missing.
It's just the X and Y are squared.
Why is it a circle?
Equation.
Yeah, because all values are squared.
Mine's right.
So like if
It's a decent response to that.
it's not gonna be
More true to that, this is two parabolas. This is two side parabolas.
So I don't have enough hands for that. Though. Someone help me out here.
Something you should have picked up earlier. Let's just do that real quick. This is going to be linear. When you see y equals x squared, that's quadratic. When you see x equals y squared, it kind of is, but it's on its side. And if you see both of them, this was actually our first lesson, I think, wasn't it, guys? It was one of our first lessons when we did this.
Circles? Yeah.
Yeah, you were in the other class. So here's the difference between them. Okay? The squares and the graphs. He wasn't here for circles. He was in another class. All right. Waterfalls. Oh. Okay, you're gonna drop that off and then go. You know what went through my mind? He said, "I'm gonna go to the restroom." So. Oh. Waterfalls. Turn it off. Go ahead. What up? Okay, go ahead. How did I know how to shade it? We tested the point, right? We had a circle, radius turned out to be 4, correct? So I'm going to test the point, and the easiest point to check always is 0, 0. If x is 0, then this is just 0. If y is 0, then that's just 0. 0 plus 0 is 0. Is that supposed to be 16? Is that a true statement? So then you shade the other side. In this case, the outside of the circle. Okay? I don't know what I was trying to write.
I wish I was taught this way, yeah.
How are you taught? Not this way?
We had to make a chart and do all of the values and then graph them and then put them on and then test the values.
This is just like
Did I not say math don't like hard? There is no señorito for a guy. There's just señor. And that's it. Yes. For a lady, there's a difference. You know the difference, right? It has to do with intercourse. A señorita is still
what's the board
Really?
comment down below.
This is why it's taking me seriously. Moving on. What? Waterfalls. Go ahead.
You plug in like 3, 3, then it becomes the parabola.
If you picked a point like 3, 3,
Yeah.
3, 3. Let's go back.
Oh.
No, it'll be 3 plus 3 squared is what?
9 plus 9.
9 and 9.
Is 18.
Whoa, whoa. Go back.
Unless that's like not.
3.
Unless it's
3
like
would be
right
on. Would be outside.
Oh, okay.
It would be barely outside.
Never mind.
It would be barely outside. Yeah, because you made me look at it like. or on the circle, but that would be true. So it would have to be barely outside. You really want to pick a point that's definitely inside. Okay. That one's a kind of a, yeah. As I look at it, I'm pretty sure that's outside, isn't it? Yeah, it is. It's outside the circle. But try like 2-2. 2-2 is definitely inside, right? All right, cool. Moving on. Are you guys okay with this? Like, is it making sense? I think we're done.
Oh yeah, that makes so much more sense.
Oh, we should do, thank you, waterfalls. We should do one of these. This is just old school two linear inequalities. In this one, I'm not going to use the intercept method because, well, I could. Yeah, that's not a big deal. Let's do that. So we've got, let me use a different color here. If I have, let's do if x is 0, then we've got -2. If y is 0, then we've got 6. Right? So 0, -2. And then 1, 2, 3, 4, 5, 6. It's going to go here. This is going to be a broken line. A broken curve.
That's a line.
Test of point 0, 0. Is 0 less than 6?
Yes.
Yeah, so we're going to shade. Now, here's where I recommend you guys, if you don't already have a box of colored pencils, you really want to do that because you're going to be able to see the different shades correctly. Looking at the bottom one now, we've got, I do love them. They're delicious. We could do another lesson tomorrow and just finish the chapter.
That's pretty smart.
If x is 0, y is going to be a -2. If y is 0, we're going to get a -3. So we have a point here again. Are we shading above? What? Oh. Thank you. Are we shading above or shading below? We're shading 0, 0? So, when we do this bit, oh my god, I didn't mean to do that. We're looking for the area that has both shades in there. Both shades in there. So, is this a solution? Is this region a solution? Is this region a solution? No, it's only going to be this solution right here. So let me kind of try to solidify it a little bit. It's all of this. Right hand. That's a Picasso. Taking pictures right now.
That is so
Waterfalls. I really recommend that you do these on paper and you shade them on paper, because when you do them on Math Lab, you're going to want to shade as you go, and it's going to be wrong because it will shade all the regions as you click them, and you're going to end up with 3 regions versus 1, and then you're going to be wrong, and I can't give you your points. So make sure that you do it on paper, know which region you want to shade, and then at the end do the shading. Okay. All right, cool. That makes us done. We'll say the rest off screen here.